Hi guys, welcome to TechoGenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello guys, welcome to the TechoGenius Academy. Today we are here to discuss the next interview session for those who are having 2 to 4 years of experience and basically those who are into the embedded domain and who are working in a Linux application or Linux device driver. So for those they interviewer will ask these questions and all. So some of the questions will be asked to the freshers also in this session. We will discuss about that, and we will try to cover as much as possible. So like earlier we discussed about that in first interview session, what are the different questions in Linux device driver they ask. So in this session we will cover the Linux system programming questions. So one by one, step by step, I was just trying to cover these questions. So these questions are basically asked by Intel, Saskin, Qualcomm, IM Plus, Nokia, Samsung. These are the companies who will be basically asked these questions and all. So what I'm gonna try to cover some of the basics questions and some of the advanced where the interview will give you some scenarios like in system programming they will tell you that you have some one global variable and you have to share it with the multiple threads, and suppose like one thread is one thread is communicating with the other thread and updating this variable. So how you will manage this variable and all this. So some of the scenarios they will just tell you that we will discuss in the advanced session. So in the basic session, what are we gonna cover? Let's get started over there. So okay, so there are approximately so there are 15 questions I'm gonna cover today. If we'll get the time, then we'll just jump to the advanced also, but first we have to concentrate on this 15 questions. So the first question is what is the difference between fork and vfork system call? So as you know very well that fork system call will create the child process. So once the child process is created, both parent and the child process start their execution from the next statement after the fork, and both process get executed simultaneously. So it will when it will create the child process, different process child process means like different process context block will also be created. Okay, and in this case both child and the parent will run simultaneously. But like a few of the guys were not aware of this vfork. So what is vfork? Okay, so it will also create the child process, but the child process suspends the execution of the parent process until the child process completes its execution. As why? Because as both processes share the same address space. So this is the basic difference between fork and vfork system call. So in the I'm just adding to this. So basically fork system call is mostly used. vfork we are not using because it is accessing the same shared space, so it will be disadvantage, or it will if some data will be corrupted or something like that. So that is a but in this fork system call, there is a wastage of address space, but in vfork there is no wastage of address space. So based on the requirement you need to choose whether to use fork or vfork. Okay, so the fork system call uses copy on write and vfork is not using as a copy on write, as because whatever the process id and whatever the different parameters available in the process control block, that will be copied to that child process. So that will not be done in vfork. Okay, so as like vfork shares the in fork, child and parent process have separate memory space, and the vfork have the same address space. Okay, so these are the things which is quite addressable in fork and vfork system call. Okay, so the next thing is what is the advantage of sig action over signals. So we are very much aware about the signals. So there are 64 signal in which 32 signals are having one number, and there are signals like alarm signal, there is sig child signal, sig pipe signal. So there are different signals we have in Linux. So on top of that, what is the use of sig action? Because there is some drawbacks in signal, so that's why we are using sig action. So what is the advantage of that? The advantage of sig action is like it give you the full control over what signal can arrive while your program handle another signal. Means like if you want to block some specific signal and allow another. Okay, okay, so if you want to know the status of your previous signal, so these are the things which can be done in sig action, but not in the signals. So that is the main advantage of sig action. So most of the guys also will ask you these things, because we are mainly concentrated on the signals, and we are not jumping into sig action and all. So that's why. Okay, so the next one is that how to map virtual address space in a user space. So the mapping of virtual address space in user space, how we can do that? By using mmap system call. So for that I need to go to the terminal. So I'll just, okay, so if I'll just do mmap, so it will say that map or unmap a device into the memory. So mmap creates a new mapping in the virtual address space of the calling process, where they have few of the parameters. If ADDR is null, so for the first parameter, then the kernel choose the address at which to create that mapping. Okay, there are another parameter also, length is also there, prot is also there. So the prot is you can say it describes the memory protection of that mapping. So we have four arguments, like we can use one of these. If prot underscore exec we will use it, it means like pages may be executed. So prot read means be pages may be read. So I think like you are you know about this pages and all. Like if you don't know, like we will discuss in the next question. So what are these pages and demand paging and all in the memory management? Okay, so these things are related to the memory management stuff. So you'll get all this information, and if you will go down, you will see one sample program also, sample application, where you can just copy paste to the terminal and check like what it is doing. So that will give you that idea that how we can map the virtual address space in user space. Okay, so the next the next question is like what is the difference between process and thread? So this is the basic question, like every like to the freshers also they will ask to that because this is the first question they will ask, and after that they will jump into IPCs, they will jump into the thread management, and they will just ask you the question in different mechanism for thread synchronization, so how you can sync the between threads. And also in this is the first question they will ask. So we will try to cover. I know you some of the guys, you know about this thing, but I just need to cover in this session. So process means like it's just some program which is executing. And thread means it's a lightweight process, like it's a segment. It's just one segment in a process. So you can have a multiple thread in a single process also. So where like in the process, like a process will have multiple parameters. So processes will take more time to create, it will more time to terminate also. I whether like okay, so in thread side it will take less time to create and terminate. So this is the one thing in process and thread. And similarly, like if it is taking more time to create and terminate in process, so the context switch also, it will take more time. Similarly in threads, it will take less time, because in a single process you have multiple threads and you can communicate between the threads easily, and it will not take much time. Okay, so it depends on the scenario, like where you want to use process and where you want to use threads. Okay, so if you have less memory, you can use threads. If where you have enough memory and you're communicating with heavyweight process, and you can use process stuff where you can use IPC mechanism and all. But the advantage of thread is like you can use IPC mechanism in threads also. So that is the advantage for threads and all. So these are the few things which is like I just told you to the difference between process and thread. Now, so the next thing is how to check whether the file is link file, directory file, or the regular file. So you know about that system called stat. Okay, so without opening the file, if you want to see the size of the file, okay, so let me just go to the terminal and let me go to lsp. This is one like folder I have, ls-li. So okay, cd ipc, okay, ls cd advanced message queues. So these are the few programs. So ls-li. So these are the files. Okay, so the size of this files and all these things, address is already mentioned here. Now without opening the file, okay, without using this ls-l from the bash shell, how we can do that? So there is a stat system call. But if we want to know that a particular file, so these are the general files. .c file is general files and all. So if you want to know whether the file is link file, or whether the file is a regular file, or the directory file, what is the exact system call? Because in link file we need to go for another call. So the call is lstat. So lstat will give you the information about that link file. Okay, so you need to check this out, like how you can use this lstat. I think I have explained in one of the session also. You need to go back and check my Linux system programming playlist. In that you will find this, and in this I can show you that how you can find there are some macros you can use. S underscore is a reg. So if you will use this thing, this is actually a mode, st underscore mode. So if you will use this, it will give you the information that a particular file is a regular file, or a directory file is a character file, because there are different files present. Like you have different files like a regular file, directory file, character device file, block device file, FIFO file, which is also named as a named pipe file, which is one of the method in inter-process communication. And the next one is the symbolic link. Is it that a particular file is a link file or not? And there is also a socket file. So there are different files are there. So using LSTAT, you can get the information about this files. Okay, so this is all about this files and all. Okay, let me go to the next question. Okay, what is virtual memory? So to more than 4 years experience also, they know about this virtual memory and all. So because the memory management concepts, these are the concepts which some of the trainers will guide you at the last, or like will tell you about the little bit about the information. But these are one of the important concept in Linux. So you need to be very careful with your aspects, like what you are saying and all. So actually, virtual memory is a memory management technique where secondary memory can be used as if it were a part of the main memory. It's a very common technique we are using in Linux system programming, and virtual memory uses hardware and software to allow the CPU to compensate for a physical memory storage. So as we know, we have RAM for the disk storage, and we have secondary memory, we have the main memory and all. So these are the things we are using. Actually, virtual memory is important for you can say multitasking. If you want to like if you're writing large programs and all, so their virtual memory comes into the picture. So this is all about actually how a virtual memory works. It's like a virtual memory uses both hardware and software to work on this. When an application is in use, like whenever you are writing the program and all, data from that process, like whatever the program you are writing, it's stored into the physical address space. As you can, physical address space is nothing but your RAM. Okay, virtual memory will map that address, whatever the physical address, to that RAM using a memory management unit. So in memory management, MMU is the heart of this thing. So suppose in CPU your some of the pages are there. In virtual memory, you are requesting some pages and from the CPU and all. So memory through memory management unit, so through MMU it will go. Okay, so it will help for like in like context switching and all this thing. So when you need to do when you want to swap the files or swap the pages and all, in that area, virtual memory will be used. So it will just increase security. It will allocate the memory in a very good manner, and it will be effective for, you can say, it will be effective for the processor, like it will helpful for the CPU and all. So pages in the original process can be shared during a fork system call. So whatever the fork system call you are using, the pages will be shared among them. So this is all about this you can say about a virtual memory. So there is another question, is a difference between demand paging and segmentation. Okay, so the demand paging is that the process of loading the page into the memory on demand is known as demand paging. So as I was explaining you, so paging is one of the memory management concept, where you need to fetch the process from the secondary memory into that main memory in the form of pages. Okay, so in this paging, each process is split into some parts where size of every part is same as the page size. Okay, so this is the concept of demand paging. But in segmentation is also a memory management concept. But in this, like, the size will not be fixed. It is having a variable size partitions. And the secondary and the main memory are not divided into some partition of equal sizes as we have in demand paging. So that is the exact difference between the demand paging and segmentation. So this you need to be take care of this question, because mainly they will be asked. Now, the next question is, what is the exact difference between multiprocessing and multi-threading? Okay, so multiprocess. Okay, so this is also the important question. You can say, like, if the multiple process has to communicate with each other, then you can say it's a multiprocessing. In a simple layman language, if multiple threads are created in a single process that you need to communicating, then it's a multi-threading. In simple language, you can say many processes are executing simultaneously, but in threads, in multi-threading, multiple threads are of a single process or a process are executing simultaneously. And in multiprocessing, every process owned a separate address space. But in multi-threading, a common address space is shared between all the threads, because you are running a multiple threads in a process. So in multi-threading, it is sharing the same address space. Okay, so that is a basic difference between the multiprocessing and multi-threading. Now, the next one is that which IPC mechanism is faster and which one is slower. So we are having, okay. So what is IPC? IPC is the interprocess communication, and interprocess communication is like, it's a way to it's a method, it's a way to communicate between different processes. Okay, so we have different IPC mechanism. We have pipe, we have name type, which is also, we can call it as FIFO. We have message queues, we have shared memory. So among these, message queues are the slower one. Why? Because in message queues, you have to do a lot of work. Because in message queues, like when you are sending some message in the queue, and from the other end the message has to be received, you have to like, in that, kernel has to maintain some data structure, so it has to go through the kernel. So you are writing into the kernel, so that data structure is there, which will slower that process. Okay, so we can say that a message queue is the slowest IPC mechanism, where shared memory is the fastest one. Why? Because in shared memory, it will share the uh, same address space, like different processes. Like if we have multiple processes, if we want to communicate with each other, they will share the same address space. So that is we can say the message queue are the slower one, and shared memory is the fastest one. Okay, so this is all about IPC mechanism. Now, the next thing is explain a process table and the process control block. So you know that what is process table and the process control block. One second. Okay, so a process control block contains information about the process, that is registers, priorities, your control block, your pointers, your process state, your process number, and all your register, memory limits, your status, and all these things. And this is the process control block. Okay, so the next thing is explain different state of process. Okay, so there are different states of the process. There is a new stage, there is a ready stage, a running stage, blocked, suspended, and all. So when the process is about to be created, then there is a new stage. Now from new it will go to ready stage. So ready means like after the creation of the process enters the ready state. So after that, when the system is running, like when the process is started, like then it will jump from ready state to the running state. Now, so just suppose like some interrupt comes up into it, so it's just suspend the stage, and it will go to some suspend stage, or if any blocking call is there, like you need if some you are putting some sleep over there, then it will go to some blocked state, or you can say a wait state. Okay, so if the process is killed, as well as your process control block is also deleted, then you can say it's a terminated, or you can say complete stage. So these are the different states of a process and all. Okay, so there is a next question is explain process scheduler in Linux. So there are three types of process scheduler. There is a long-term scheduler, there is a short-term scheduler, and there is a medium-term scheduler. So you can get this information over the internet. But I can explain you. In long term scheduler, it brings the new process to the ready state, and whatever the number of process present in the ready state at any point of view, it will be there. And it's just important that the long term scheduler make a careful selection of both IO and CPU bound process. So what is CPU and IO bound process? If the process is intensive in terms of CPU operations, like whatever the CPU bound operations if you want to do, then probably it will be the CPU bound process. So if the process is intensive in terms of IO operations, then it will be IO bound process. Okay, so this is all about the CPU and IO bound process. And the next one is a short-term scheduler. It's just responsible for selecting one process from ready state for scheduling onto that running stage. So that is a short-term scheduler. And the medium term scheduler is responsible for suspending stage and the resuming the stage. It will just responsible for suspending and resuming the particular process. So it will mainly do the swapping of that process from the main memory to that from the main memory to the disk, or you can say from the disk to the main memory from that. Okay, so this is the main term in medium term scheduler. Okay, so the next thing is CPU scheduling. CPU scheduling is like you are running a particular program in a particular process. Okay, so now you want to release that CPU, and you want to jump to that another process where your scheduling of process or whatever the program you are writing in is done, and finish the work, and that is in that CPU scheduling comes into the picture. So in that scheduling there will be different terms with respect to the process will come into the picture. It means like arrival time, so the time at which the particular process arrives in the ready queue. ready, like in the ready stage and all. And there will be the completion time, there will be the burst time, like the time required by a process for CPU execution. There will be a turnaround time. The turnaround time is the difference between completion time and the arrival time. Okay, so there'll be a waiting time. So the waiting time is basically the difference between the turnaround time and the burst time. Okay, so basically why we do need scheduling means like it involves both IO time and the CPU time. So if you have a single like a single CPU programming system like DOS or something like that, then it'll spend time for waiting for IO to complete, and after that the CPU will be free during that time. But in multiple programming system, one process can use CPU while other can use IO. So this is only possible in process scheduling. So you can switch between the process, and also you don't need to wait or something like. So in single processor system, it will be difficult. Your system will be slower. So if you are doing multi programming, so in that process scheduling will help you. This scheduling, CPU scheduling, will come into that picture. Okay, so the next thing is primitive scheduling and the non-primitive scheduling. Okay, in primitive scheduling, you can say it'll allocate the process for a limited time. So like you are running some program, now your task is completed, now you need to release the CPU, and you need to jump to that another process. Then you can say it's a primitive. Or non-primitive is like whatever it is, like it will not jump to that other process and all. Suppose you use some locking into some threads or something like that, or it is not releasing that CPU, then it will come to that non primitive scheduling. Okay, so process can be interrupted in between, so you have to switch with that. And in non-primitive, if a process will come, so it can't be interrupted, and it can't go to some other stage and all. So a few of that scheduling algorithm is used here. So example of primitive scheduling, you can say a round robin and shorted remaining time first. So whatever the shortest job first, so whatever the shortest job is there in the process, that will come and that will complete the process. So whatever the remaining time occurs, so that is the shortest remaining time first. And the non primitive scheduling techniques are like first comes first serve, and the shortest job first. Okay, so these are the things. So explain different methods in a scheduling process. Okay, so different methods are like first come first serve, round robin, shorter job first, longest job first, and this one, the shortest, whatever I was explaining you in this earlier one, this shortest remaining time first, longest remaining time first. So these are the different methods in the scheduling process. Like first come, like whatever the process comes here. Okay, first come, as you can say, is a queue. Okay, so queue presents in that. So so these are the different things. So round robin comes into the primitive. So if you want to release that process, and your release the CPU, it will release. So that will come in the primitive. So these are the different algorithm are there. So these type of question probably they will ask you. So this is quite enough I have explained in this session. I will come back, and I will explain you the advanced scenarios, advanced Linux system programming questions, where most of that questions will be the program. So if any scenarios are there, so maybe like we can discuss and we can write the session. So hope you like this session of mine, and thank you so much. So if you like, please don't forget to like, share and subscribe, and thank you so much. We will touch back later. Thank you.